as if things are not confusing enough, we can now put everything we learned together into the following example. Let's find a function whose Laplace transform is 3 times s minus 2 over s squared minus 4s plus 5 times e to the minus 3s. And the trick is to first focus on this part. So step 1. So first focus on 3 times s minus 2 over s squared minus 4s plus 5, and then figure out what happens to the exponential term. And here what we need to do, as usual, the bottom is a quadratic, so we need to complete the square. So 3 times s minus 2 over s squared minus 4s plus 5. So that's 3 times s minus 2. And then remember how to complete the square. So you do s minus 2 squared. So half of minus 4. And then you remove this squared. So minus 2 squared plus 5. And that becomes 3 times s minus 2 over s minus 2 squared plus 1. And remember, if this bottom weren't s minus 2, you would use that trick of s minus something plus something, wherever you have your shift. But here, we have the same thing, and now this thing is a shifted version. This is a shifted version by 2 units of 3s over s squared plus 1, which I believe is a Laplace transform. Again, 3 times s of this, so 3 cosine of t. So this 3s minus 2 over s minus 2 squared. This one. S minus 2 squared plus 1 is the Laplace transform of e to the 2t. And then 3 cosine of t. If you want the Laplace transform, you can optional 3 e to the 2t cosine of t. Now, that was the thing without the exponential function. So we just focused on this part so far. And now let's see what happens when you add this e to the minus 3s. So step 2. So what do we have? We have this e of minus 3s times this 3 times s minus 2 minus 2 over s minus 2 squared plus 1. Now we saw this is e of minus 3s times the Laplace transform of 3e to the 2t cosine of t. But now we use the rules we learned in cases 1 and 2. So what happens when you add an exponential term to the Laplace transform? Remember, it shifts and jumps. So what we end up getting is Laplace transform of 3 e of 2, I believe t minus 3, cosine of t minus 3 and u3 of t. And I know it gets a bit confusing with those minus signs, but remember, I will also give you all those formulas. So it's nothing to really worry about. So what is the answer? The answer is precisely this. Our mystery function is the Laplace transform of 3e to the 2 times t minus 3 cosine of t minus 3, u3 of t. By the way, no need to expand this 2 times t minus 3. It's completely fine. All right, very good. So those are all the rules that we needed. Next time, what we'll do, we'll solve ODEs using those shifts and jumps. And you'll see, it'll be super cool.